Did you know that the active chemical in magic mushrooms, psilocybin, can rewire and make the human brain more flexible, translating into major therapeutic benefit in depression and other conditions? This has led to Australia approving specific medicinal use of psychedelics as the first country worldwide. You will be surprised to hear that psilocybin can be synthesized in just 4 steps, leveraging quite simple chemical reactions. It was the legendary Albert Hofmann who synthesized it first, and just like with his discovery of LSD we've seen in another video, reported a self-experiment which didn't just make him trip big time, but also unveiled some salient characteristics of this molecule. This story is not commonly talked about, so I hope you are in the mood for some 60-year-old German texts. Oh, and just like heroin, psilocybin was sold as a legit pharmaceutical. You gotta love 20th century chemistry. So today we will review psilocybin's rich history, chemical structure and mechanism of action. Then we will look at its chemical synthesis, dive into the scientific evidence behind its therapeutic potential, and last explore its effect on brain networks. Let's be clear, this video will not contain recommendations or information on taking magic mushrooms. There's a recent podcast from the Huberman lab which is a great resource if you're interested in the practicalities and more details. Don't use this video to inform or rationalize your personal drug use, and definitely don't take psilocybin or other psychedelics if you have a predisposition for or family history of psychosis or bipolar disorder, or if you are below 25 years old because your brain is still developing. Psilocybin is a so-called tryptamine alkaloid found in a variety of mushrooms, but most potently in the genus Psilocybe. Due to its hallucinogenic and mystical effects, human use of psilocybin for medicinal and religious purposes dates back to prehistoric times. Some notable artifacts include the Spanish cave painting, though maybe this person simply liked champignons, or more telling mushroom figurines and even statues from prehistoric Colombia. Apparently the mushrooms were called God's flesh in an Aztec language, so you can be sure they were tripping big time. Supposedly the oldest indication of human use was found in an Algerian cave, estimated to date back to an insane 7,000 to 9,000 years BC. It shows what we probably all drew at one point in our life: transcendental, bee-faced mushroom shamans. Jokes aside, do you think that the interpretation on the far left is sensible compared to the original? Some folks argue that it's very easy to overinterpret these types of drawings and immediately think that magic mushrooms are encrypted everywhere. Also, don't forget what exposure to the elements over thousands of years can do. What looks like a mushroom to us might have represented something else. By the way, the esoteric drawings in the Algerian cave naturally also make it a prime site for ancient alien enthusiasts. Given Europeans prohibited mushrooms and other non-alcoholic intoxicants in the 16th century, their use was driven underground. So much so that during the early 20th century, Western academics weren't even sure if psychoactive mushrooms existed at all. They didn't see the convincing Algerian shamanic cave drawings yet, so they are excused. This changed with Gordon Wasson, a banker at JP Morgan and investigational mushroom connoisseur who took some trips to remote Mexico with his wife in 1953. Albert Hofmann wrote that it took more than one trip for Wasson to participate in a mushroom ceremony instead of just watch, and that he might have been one of the first white folks ever to take them. A few years later, in 1957, Wasson published the first ever broadly distributed article on magic mushrooms. I invite you to look through it yourself, the link is in the description. Not only is it nice to read through his personal expeditions and experiences, but flipping through this 70-year-old magazine itself is quite hilarious, partly because it has some nice old-school ads for things like canned meatball pasta, or the inviting flavor feast of canned pork and beans. In 1957, the chemistry and biology behind mushrooms was still a mystery. But even though Wasson thought chemists have a long road to go for isolation and synthesis, this would change very soon. By the way, if you like this video, please consider becoming a member or Patreon if you would like to support the channel. Wasson was connected to the botanist Roger Heim, who was a man with vast experience in the field of mushrooms. Heim managed to grow the Mexican mushrooms in his laboratory in Paris, so he's like the founding father of shroom farming, and shared samples with the Swiss pharma company Sandoz, where the legendary Albert Hofmann was still active, having already discovered LSD more than 10 years earlier in 1943. Hofmann soon isolated psilocybin and its active metabolite psilocin, but how? He first tried something I mentioned in an old video talking about the mind-blowing isolation of 0.35 milligrams of ciguatoxin, a marine natural product, from 125 kilograms of moray eel guts. During that effort, the scientists injected their chromatographic fractions into mice and determined presence of ciguatoxin based on if the mouse would drop dead or not. Hofmann tried to do something similar first, as we can see from a longer publication of his in 1960. Feel free to pause the video so you can digest and enjoy the text without a rush. From Heinz Shroom Farm in Paris, they first performed animal experiments with different fractions to guide the isolation. Before you get your hopes up, piloerection is just a fancy word for goosebumps. However, both tests in mice and dogs were not conclusive, as the effects were not clear and differed across fractions. If you watched my awesome video on LSD already, you would know that in addition to the pupil twitching that Hofmann mentioned, head twitching of mice is also a proxy for trippiness. Just to prove my point, like we saw with LSD, a significant increase in twitch events can be observed with psilocybin doses of higher than 1 mg per kilogram of body weight. You can also see this reflected in how and how much a mouse moves around. So after these unsatisfactory animal tests, the temptation got too big. Hofmann ate 32 medium-sized mushrooms, talk about not being cautious at all, and the ensuing effects left no doubts regarding the potency of these fungi. After half an hour, Hofmann started to experience some serious sensory disruptions and hallucinations, apparently even accepting the fact that his supervising doctor might sacrifice him to some ancient Aztec gods. His trip peaked 1.5 hours after eating the mushrooms, and the entire psychedelic dream lasted about 6 hours. As you can tell from his text, he came back feeling quite euphoric. This trip made him realize that the potency of mushrooms was not the problem, but that animals are less sensitive in terms of their response to psychedelics. You can also see this in today's research in animals, which uses doses that are usually more than 2 to 3 times higher than human doses. So with this confidence and insight, Hofmann consistently performed human testing of extracts to guide the rest of the isolation, which worked quite well even though these were diluted samples and not dried potent mushrooms. Which of Hofmann's self-experiments do you like better? The LSD bicycle story or the Mexican mushroom fiesta? Let me know in the comments. Wrapping up on history before we go to chemistry. Hofmann also rapidly developed the first synthesis of psilocybin in 1959. Thereafter, Sandoz distributed 2 mg dose tablets, nucleating several clinical studies in the 1960s and 70s on mental disorders and other investigational areas. However, as part of the war on drugs to control abuse of psychedelics, psilocybin was classified as a highly controlled Schedule I substance. Only after strict governmental controls were somewhat lifted by the 2000s, psilocybin became the subject of clinical investigations again and recently picked up even more steam with the FDA granting psilocybin a breakthrough therapy designation in 2018. Before we talk about these studies, we need to take a closer look at psilocybin itself. Comparing the chemical structure of psilocybin and its active metabolite psilocin, you will see that they share the tryptamine core with various other compounds. For example, with the endogenous neurotransmitter serotonin, which modulates mood, learning and other things in humans, but also the hormone melatonin, which modulates our sleep and circadian rhythm, and of course other psychedelics such as DMT. It's always impressive to see that simple changes in chemical structure lead to massively different physiological mechanisms of action. But wait, what's the connection between psilocybin and psilocin? Well, just like aspirin, psilocybin is a prodrug, which in this case is rapidly dephosphorylated under acidic conditions in the intestine and liver. After first metabolism, the resulting psilocin is much less hydrophilic and only can now cross the blood-brain barrier. Once in the brain, psilocin is believed to selectively bind to the serotonin 2A receptor. With psilocin looking quite like serotonin, it engages in similar interactions in the active site of this 2A receptor. This receptor is highly expressed in certain brain regions and part of a much broader family of 14 subtypes of serotonin receptors, which drive the incredibly broad biological functions of this neurotransmitter. Psilocin is believed to get its therapeutic effect from its selectivity for the 2A receptor over other serotonin receptor subtypes. However, there's also some research showing that affinities for 2A, 2C, and 1A receptors are around in the same order of magnitude. So clearly the picture is much more complex. These receptors are so-called G-protein coupled receptors or GPCRs, which if activated lead to an array of complex downstream signaling cascades. These molecular mechanisms, most of them not well understood and involving other neurotransmitters like glutamate as well, result in structural and functional cellular changes which can translate into enhanced neuroplasticity. Just want to mention that I will not cover how other antidepressants or serotonin specifically work because this video is already really packed with information. Let's remember a typical psilocybin session is just 4 to 6 hours long with a peak of acute subjective effects after around 60 to 90 minutes. For example, due to the high expression of serotonin 2A receptors in the visual cortex, individuals experience visual hallucinations at high doses even with their eyes closed. This heterogeneous receptor expression in brain regions is something you should remember for later, by the way. It's really interesting because on top of these acute effects, there are these cellular changes we've mentioned which happen on a much slower but also more durable timeline. So neuroplasticity refers to the brain's ability to change throughout life and can be driven by changes in cell structure, but also changes in the efficacy of synaptic transmissions. From these different mechanisms, I just wanted to highlight one study on dendritogenesis. This team of researchers looked at structural effects of psilocybin in mice. To validate effects and dosage, we once again have the good old head twitch response. Within the frontal cortex, they found a significant density and size increase of dendritic spines. These are neurons' protrusions which help signal transmissions across the nervous system through synapses. Strikingly, a fraction of these new dendritic spines was still present after a month, and they seemed no different than normal spines. This is clear evidence for structural change from psychedelics. Now we have a twist. They also pre-treated other mice with ketanserin. This compound, you can see that its left half looks like a tryptamine analog, is also a strong 2A receptor antagonist which leaves many receptors inaccessible to psilocin activation. This blocking or knockdown is reflected in the lack of a head twitch response, as you can see here. However, the structural remodeling took place nevertheless. It might be that this happens already at much lower concentrations of psilocybin, or potentially also proceeds via other mechanisms beyond serotonin 2A receptors. Now that we understand psilocybin's rich history and some basic biochemical mechanisms, we can check out some organic chemistry. The research we will talk about is a synthesis of psilocybin by scientists at the Usona Institute, which runs early research and clinical trials for psilocybin and 5-methoxy-DMT. This is a non-profit medical research organization which is pioneering the application of psychedelics to neurological disorders. They even have an investigational supply program of the psilocybin that they synthesize themselves. Let's check out how this works. Psilocybin can be made from psilocin, a slightly simpler molecule of course, by essentially reversing what would happen in the body. Albert Hofmann's first synthesis published in 1958 and most large-scale routes accomplish this in 2 steps. First, psilocin nucleophilically attacks an activated pyrophosphate. Interestingly, one of the benzyl groups hanging on the phosphate oxygen intramolecularly shifts to the nitrogen, creating a Zwitter ionic species. The nucleophilic substitution on phosphorus would have been ineffective without the benzyl or other ester groups, but now a hydrogenation is required to deprotect the intermediate to psilocybin. It seems straightforward, but this approach has quite a few challenges, most notably that atom economy is quite bad. Starting from 700 grams of zwitterion, just 100 grams of psilocybin can be isolated. In addition, the benzyl migration step to nitrogen is quite poorly understood and behaves in funky ways, which makes in-process monitoring tricky. Obviously, you don't want to start randomly guessing reaction endpoints when you are doing a reaction on kilogram scale and need to tightly control for side products. This transformation is very dependent on reaction volume and temperature control. The authors highlight that in one reaction gone bad, they had to filter the product over 6 days. Instead, the Usona team discovered a more efficient way. Let's look at the full synthesis in just 4 steps from the commercially available starting material. 4-acetoxy-indole can undergo a regioselective electrophilic aromatic substitution with oxalyl chloride to introduce the 2-carbon chain. In a second step, the remaining acyl chloride facilitates an amide formation with dimethylamine. Adding lithium aluminum hydride at forcing conditions, we exhaustively reduce both carbonyls on the nitrogen chain, liberating the tryptamine, as well as the acetyl group to give the free phenol in psilocin. Now, under optimized conditions, the authors found that using POCl3 followed by immediate hydrolysis introduces the phosphate quite cleanly. They were able to scale this very well, delivering a whopping 1.2 kilograms of psilocybin in just one go. This phosphorylation proceeds via stepwise hydrolysis of the dichlorointermediate, but as you can see, the reaction setup and workup is quite complex at scale, and this step still remains the most problematic one in the synthesis. For instance, they had to add 3 kilograms of sea light powder to prevent the formation of sticky precipitate that messed up the stirring. The hydrolysis itself was achieved by quenching the dichloro product in a cold THF water mixture containing excess triethylamine as a base. Keeping the slurry at sub-0 degrees for roughly 60 minutes seemed to work well. Unsurprisingly, in case of longer hold times, they observed decomposition of the product to psilocin again. After some more workup, they performed a recrystallization to isolate 1.2 kilograms of highly pure psilocybin that can be used in clinical trials. So you've probably heard various people, including drug abusers themselves, throwing around the idea of psychedelics being the be-all end-all super medicines. Indeed, there is a growing body of evidence for psilocybin, but the focus is really on depression, in particular cancer-related and treatment-resistant one. Most of these studies use 1 or 2 25 mg psilocybin doses separated by around 3 weeks, and the treatment is generally supported by targeted psychotherapy sessions as well. So these patients are not just taking psilocybin to their liking in their room alone and are magically getting better. Also, most credible research is looking at pure psilocybin instead of magic mushroom bites. This way, the effective dose and safety for patients can be ensured. You don't want to give your patient some random mushroom and hope it was some good stuff. However, to give credit to nature where it's due, there's also the so-called entourage effect, which postulates that the sum of the parts in psychedelics might lead to a greater synergistic effect compared to the individual compounds. Some research has shown that magic mushrooms might be a more potent source of psilocybin than pure psilocybin itself, likely because there are other compounds and even psilocybin derivatives that have synergistic interactions and can amplify efficacy. There's really strong evidence from the largest psilocybin depression study to date published just a few months back, and this research has triggered quite some broader public attention on psilocybin. Before we go there, I wanted to briefly showcase that some evidence in other disorders is quite promising as well. One randomized clinical study compared 2 cohorts of around 50 heavy drinkers undergoing psychotherapy. Compared to another tobacco use study which only had 15 patients, this sample size is really not that bad. The black arrows indicate the timing of the 2 sessions where they either received psilocybin or a sedative which served as a quasi-placebo and blinding control. Their results were that the psilocybin group had much lower alcohol use even half a year later, also translating into fewer alcohol-related issues like physical problems or impulse control. Let's switch gears now, looking at this very large eye-catching study on treatment-resistant depression. Resistance in depression is a huge problem, as remission rates across courses of therapy drop by a large chunk. The average success rate of a first antidepressant course is only around 37%, but it drops even lower to mid-teens after 2 or more courses. Once someone failed 2 different courses, their depression is classified as treatment-resistant. This phase 2 study included 233 patients and tested 3 doses. A high dose of 25 milligrams, which isn't crazy high really, a medium dose of 10 milligrams, and a 1 milligram dose which they call a control. Not really a true placebo, but probably also too low to show any real effect. Because the acute effects of psychedelics are so strong, the value of placebos and double blinding itself is quite questionable in these trials anyways, as each participant and staff member realize who's actually tripping or not quite fast. I said it a few times already. Psychedelics can also be dangerous or counterproductive in some cases. If you're interested, you can read through the exclusion criteria for this study. Also, the study had participants discontinue antidepressants and other prohibited medications during a washout period upfront. Looking across the ingoing randomized groups, 60 to 80% of patients were severely depressed as measured with the MADRS depression scores, and around 80% had failed 2 treatments for their current depressive episode. Notably, less than 10% had already used psilocybin in their life. This might be important because some researchers have hypothesized that previous psychedelic exposure might impact trial enrollment and efficacy on individual patients. The treatment consisted of a one-time psilocybin dose which was administered in a calm, supervised environment, with patients chilling out to a nice playlist and laying around in introspective for a few hours. What were the effects? The medium dose of 10 mg did not bring any changes compared to the low 1 mg control. However, the 25 mg group showed a mean drop of 12 points in the depression score, which was significantly lower than the other 2 doses. Looking at evolution over time, we can see a steep acute drop followed by a slight rebound. However, the separation of the 3 groups seemed to persist over time. At 12 weeks, the changes in score translate into roughly 30% of patients dropping below a score of 10, which means they are depression-free. Considering we are talking about treatment-resistant depression here, this remission rate is very meaningful. Also, remember we're just talking about a single psilocybin dose here. Looking at safety, the 25 mg group had a few more adverse events, but this was primarily driven by headaches, nausea, and not serious AEs like suicidal ideation. I hope this gave you a more detailed look at why some folks are excited about psilocybin in depression. But bigger and longer trials are needed to replicate these results at scale, bring more insights into durability of response, and potentially even investigate the effect of multiple doses. In this final section, we will play neuroscientists. One potential reason for psilocybin's activity is connected to large-scale brain networks which govern all of our thoughts and actions. There are many different networks depending on what model and definitions you consider, but there are 3 that are important for us now. The default mode network is a set of interconnected brain regions that are active when a person is not engaged in any specific task or actively thinking about something. This network is often referred to as the resting state network, as it is active when the brain is not focused on external stimuli, and thought to be involved in self-reflection, future planning, as well as social cognition, so thinking about the mental states of other people. The executive network, on the other hand, is involved in goal-directed behavior, decision-making, and working memory. This network is active when a person is engaged in a task that requires concentration and effort, such as solving a complex problem or completing a difficult math equation. The salience network is another important network in the brain which is involved in detecting and responding to important stimuli in the environment. This network is active when a person is presented with a novel or unexpected environmental or emotional stimulus, such as a loud noise or a sudden movement. These interconnected networks are associated with cognitive control and flexibility, ultimately managing processes like learning and task switching. In depression or disorders exhibiting cognitive inflexibility such as autism or OCD disorders, the interdependency and switching of these networks is impaired. Research published in 2022 looked at this and showed that 2 doses of psilocybin with psychotherapy swiftly decreased symptoms in severely depressed patients. Nothing shocking for us. But what's more interesting is that psilocybin showed strong, significant decrease in brain network modularity, as shown by fMRI brain imaging. In the bottom right chart, you can see that default mode network activation decreased, while its integration with the executive and salient networks increased. In plain English, this kinda made their brain more flexible. They also had a control arm which administered a selective serotonin reuptake inhibitor antidepressant, which lacks this integration-inducing effect. The researchers postulate that this decreased modularity or increased flexibility of brain networks are key to psilocybin's mechanism of action. Depression can be characterized by abnormally constricted network connectivity, so psilocybin might ameliorate this by broadening mental states, in line with the liberating emotions some people feel. This effect differentiates psilocybin from other SSRIs, likely due to its more targeted effect on serotonin 2A receptors, which are highly expressed in regions linked to these networks. There are probably some other additional mechanisms at play here, like reduction of amygdala response, which is another pivotal area implicated in depression. Another area of interest is the claustrum, a thin sheet of neurons located in the central cortex, which also shows a high level of serotonin 2A receptor expression. In other research, psilocybin was demonstrated to decrease activity or effectively turn down this area, which is highly interconnected and also involved in setting attention and switching tasks. You can see that there are some different effects from psilocybin on the right claustrum, decreasing connectivity with some networks but also increasing others. Put simply, shutting down the claustrum might explain why psychedelics help with resetting rigid thought patterns, and why they can unveil new psychological insights through an effective rewiring of brain networks. A final interesting point is related to different people experiencing different types of trips, if you will. There is some degree of association between brain structure and personality dimension, as well as risk factors or pharmacological treatment response. In one 2020 study, researchers found that the thickness of the anterior cingulate, a brain compartment connected to other areas known to be important for emotion or memory, can predict the emotional experience that people get from psilocybin, in terms of feeling strong emotions of bliss, unity, or others. This might be one of dozens of other factors that dictate why people react quite differently to psychedelics or drugs. I hope you learned a bunch of new interdisciplinary science facts today. If you liked this video, please subscribe, consider becoming a channel member, and activate notifications for future videos. Thank you, and until next time.